Saxon's Calculus, Lesson 36, is about exponential growth and decay. So if you recall, the formula is the amount that you have after time comes from the original amount multiplying with the e, that is the e you're expecting, 2.7 estimation. And then its exponent is a constant, again, why that's a k, I don't know, and multiplying with the time. And so there's your basic equation. The graphs are super basic, going up or going down depending on whether it's exponential growth or decay. Now technically it's gonna like zero out there because once it gets to the bottom it can't go any further, so it's gonna stay stuck there. And then this would be the a sub 0 amount written here, and you don't even really have to list the times at the bottom. All right, so now let's jump to, well, let me read the initial value, initial amount, time is given, amount is unknown. Yeah, we're good. Okay, so example 1. The number of bacteria present at noon was 400. 9 hours later, so my original amount is 400. 9 hours later, so E, I don't know the constant, the time is 9 hours later. The bacteria number's 800, so after that time it's 800, so it's increasing. Assume exponential growth and find the number of bacteria present at noon the next day. So the first thing is to solve for the constant and then use it to solve for noon the next day. So you're going to do 800 divided by 400, that's going to leave you 2 equals e to the 9k. And then to remove the e, you want to natural log, and if you do that to this side, you need to natural log 2. That's going to turn it into a decimal and lose the e, so that is 0.693 equals 9k. Divide by 9, so then k is 0.077. or whatever, depending on where you round. And now we want to find the time. The original amount is still 400. Our constant is the 0.077. And now the time that we're dealing with here is from, the original was noon to noon. So that is going to be 24 hours. Now we're going to do 0.077 times 24. On the calculator, give that as the exponent to the e. Multiply that by the 400, and you should come up with fairly close to 2,540 bacteria. And remember that word problems need to have a word with them. And didn't ask for a sketch. Nope. So you don't even need to do that. They show you one there in the book, but you don't have to do it. Example 2. The number of bacteria present when the experiment began was 1,200. After 100 hours, 100, and I don't think we know our constant, there were 2,700. And assume exponential growth and then find the time required for the number of bacteria to increase to 30,000. This time it does ask for a sketch. So repeat exactly what you just did. 2,700 divided by 1,200 is going to give you 2.25 equals e to the 100k. Natural log both sides to kill off the e. Now you get 0.811 if I round it, equals 100k. Then the constant is, divide that by 100, 0.00811. And now it wants the amount after so much time has gone by. 1,200 is still the original amount, e. The constant 0.00811 is multiplying with, oh, wait a second. It told me a number, didn't it? Yes, it did. I do know the a sub. It's 30,000, and we're solving for this t. There's where the difference is in these examples. So 30,000 divided by 1,200. Again, you're going to natural log that to kill off the e. So when you do that first divide, it's 25. Then you're going to natural log the 25. 0.00811t. That's going to cancel off. So your decimal is 3.219. Equals 0.00811t. Divide by that. Time is approximately 397. And then I need to know, is that in hours or minutes? What did it say in the original? Hours. So it's 397 hours. Now this one did ask for a sketch. So we know that we started with 1,200. So just somewhere we're going to put a dot and label that at the 1,200. It is growing, as we know, so it's increasing. So you're just going to draw a curve indicating that it is increasing, and there's your rough sketch. Example 3. The amount of substance initially present was 400 grams. After 90 hours only, e to the 90, don't know the constant, we have 380 grams remain. Assume exponential decrease and determine the half-life, we'll come to that, and make a sketch. Okay, so again, 380 divided by 400.95 equals e to the 90k, natural log both sides, kill off the e, so that's negative 0.051 equals the 90k. And notice that when it was decreasing, I get a negative when I natural log. When it was increasing, I didn't get that. Just an interesting, it will always do that. And then when I divide by the 90, my constant is negative 0.00057. And now we come to the half-life part. So in the original equation, when it says half-life, it means I'm going to get a half when I do this division. So I don't have to stop and figure out what the half number is and fill it in here. I know immediately that this is going to be a half and my e and then my constant time. So 0.00057 and my time. Now, I think it wants me to find time, right? Assume exponential, determine the half-life of. Yes, okay. So we're going to natural log the half. That will kill off the e. So that's negative 0.693 equals 0.00057t, divide by that, and my time. Oh, I failed to write that as negative. I should have written it negative and negative. My brain was going, wait a second, I can't have a negative time and a negative divided by a positive, but yes, if I fill in my negatives correctly, negative divided by negative is positive, we are good to go there. So that's 1,216, and the dimensions were in hours again. So the time, there we go, we have solved it, and it says make a sketch. So we started with 400 being labeled here. It's decreasing, so we just need to do a rough sketch showing that it's swooping down.